So, good afternoon, everyone, and welcome to this lecture. We are into lecture number 5, and we need to quickly move on from this to the next topics. Anyways, just came across a question, and I thought that I will give it to you. So, this is a simple, not a simple question. This is a question which is more of a question of maths rather than a question of physics. So, I'm giving it to you. Solve it and tell me the answer. So this is a question. Two resistance R1 and R2. The series and parallel equivalent is written as n by 1. So when you join them in series and when you join them in parallel, the ratio is n by 1. Which one is the correct relation? So I'll give you 2 minutes to handle this question. Do it fast so that I can move ahead in life. So what is the answer, sir, for this one? Huh? Option D is the correct answer. Should you have taken so long to get this? Huh? Remember, your JEE is just a speed, just a test of your speed, and you have to improve your speeds. What I am finding here is your speeds are not good enough. Resistance in series divided by resistance in parallel is equal to N. That means R1 plus R2, resistance in series, divided by resistance in parallel, R1, R2, upon R1 plus R2. So this square is equal to N. As soon as you get it, you get your answer. How? Physics is only up till this point. Physics says bye bye. I'm going. Push. Physics is gone. What remains is simple maths. And what is the simple maths you have to apply? R1 plus R2 divided by root of R1 R2 is equal to root over N. And one more step you do, which I will not do. Because if I do everything, what will you do? You will only chill out. The answer is D that you get from here. Should it have taken centuries to solve this question? You've taken centuries. Not good, not good, not good. Utterly disappointed with your performance. Well, then I have to keep the disappointment aside and I'll have to move ahead in life. And this was a revolutionary question asked by some of you. And I could not, this is the best I could get. Whatever picture you had sent, this is the best I could get. This is the question. An aluminum wire is carrying a current of the diameter of this. Electric field in the wire is this. Everything is given. What do you want me to solve? Tell me. Everything is given in this question.
Not this question, sir. Below this question. 12th one. 12th question, sir. Below this question.
I can only get this question. What was below this question? It was the question of that truncated cone. Yes or no?
Sir.
I gave you the formula for that question. Look at the formula, put the formula, get the answer, and stay happy. If you don't remember the formula, go back and see that class. Okay? That truncated cone you are asking, na? Huh? Radius A, radius B, or what? Nah? After this, that was only question. Question number 12. Truncated cone, a cylinder of length L, ununiform, non-uniform cross-section area. I don't know in which universe do you guys live. And we really need to know that universe in which you live. Don't remember the universe in which you live. Somehow you get lost in any hidden dimension and you just go away. Lost in some hidden dimension. Do you guys stay in the class or not? Does any one of you remain in the class or not? No one remains in the class. I have
It's
to
still,
remain
sir.
in the class.
It is for resistance.
Hey, 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 la 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 la, la 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 la, la 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 la, la 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 la, la 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 la, la 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 la. This is again from your notes only. You have to remain in this universe. All of us has to remain in this universe, in the same dimension. 4% of the universe we see. SC Verma, I gave you this. I gave you the answer also. Anyone was chilling out or lost in some other dimension. Isn't it? Remain in this dimension, my dear friend. This is a good dimension and a good universe to live in. Okay? I love this dimension. I love this universe. You don't. Because all of a sudden from the class, whoosh, you just take some interdimensional portal and you just get on the other side. So that is why I don't remember what happens in the class. There's not even a single thing that I have not told you. The only thing is we don't recollect. The only thing you have to forget is that you have to forget the habit of forgetting things. That is the only thing you cannot forget. You keep on forgetting things. And I can only pray to Almighty that, hey, Devi Ma, Lord Vishnu, Jesus Christ, Allah, Akbar, everyone, help these people.
Sure, sir.
Help these people that they can forget the habit of forgetting things. Chalo. On that atrocious note, let us move ahead in life, because no matter what, even if you don't remember anything, it's my duty to complete the course. And I shall not refrain from my duty. I'll have to complete my duty. I know that this is all going down the drain of Hyderabad, but still, I like to fill Hyderabad drains with all those things that I do. So let's fill the Hyderabad drains more with this next thing that will again go down the drain. And this is known as maximum power transfer theorem. What's happening? Why it is getting disappeared? Hmm? See, you are looking at your nature. This thing also got angry. I will not be uh, I will not be put down the drain of Hyderabad. I hate drains of Hyderabad. Very dirty they are. Drains are dirty always. But your students want to be in the drains of Hyderabad. I am not going to be the part of it, and therefore I hang up. But then I bring her back. Come, 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 come. There are good things also in Hyderabad, apart from drains. Okay, so let's not put things down the drain and let us move on to the next thing. Maximum power transfer theorem. Maximum power transfer theorem. So what is this maximum power transfer theorem? Obviously, you don't know it right now. After 2 days, it will be down the drain. But still, for that 2 days before going into the drain, let's see what this theorem can help us with. Maximum power transfer theorem, it is known as. And how does it help? Apart from filling the drains of Hyderabad, what does it do? It does this. So this is a gentleman. This gentleman is a what? Is a battery of EMF E and internal resistance R. We'll now, after this, we will go into that internal resistance thing. This is a battery of internal resistance R, small r, and EMF E. And you must understand the function of a battery is to give power, to deliver power to whatever is on the other side. Now, this thing on the other side, the green one, is the load. It is known as the load. This thing here is known as the load. Load, whatever is there, it's load. It could be a fan. Fan is here. This could be a fan. This could be a light. Anything. It's load. Now, what this load wants, what this whatever instrument is this, it wants is that maximum power must go to this. Now, this battery also wants to deliver the maximum power to this load. In what condition does it give maximum power to the load? Now, what we are going to do is I'll give you a series of questions that will encompass everything that we want to know about this circuit, and we will solve them one by one. The first set of problems are from A to E. You don't have to plot the diagram. I will show you that plot. What is the current in this circuit? Number one, power output. Now, whenever we are talking about power output, is the power which is delivered to the load. Power output is power delivered to the load. Relation between R, small r, and capital R, so that maximum power is given. Value of maximum power. Plot the graph between power and resistance. I will show you that graph. These are the first set of problems that you have. And you have 2 minutes to show your talents. And let not things go down the drain. 2 minutes you have. So how are we supposed to do this? This question has been broken up into small, simple parts so that we can understand it. The first part is pretty damn simple. The current in the circuit, if I call this current as I, we can very easily see that this I will be equal to E, the EMF of the battery, divided by R plus capital R. No points for guessing this one. It is as simple as it gets. Point B, the power output. Now, whenever we talk about power output, it is always power delivered to the load. I square into R is the power, so we can simply find the power. E square upon R plus capital R, the whole square, times R. Now, the third part, again, physics has got nothing to do with this. The third part, you have to find out the relation between small r and capital R so that the maximum power is given to the resistance load R, capital R. How will you get that maximum power? The condition for maximum power? Huh? To find out the maximum power, you have to differentiate this with respect to R. Depending on what is your variable, you can take small r. Normally, I've written it wrongly. The variable quantity is capital R because internal resistance of the battery is constant. You cannot change the internal resistance of the battery, but you can change the external resistance, and depending on the external resistance, maximum power can be delivered to R. You find out dP by dr and equate it to 0. This is how you find out maxima and minima of a function, and I know differentiation is already over. So you must be knowing this. So what I'm going to do is I'm going to differentiate this, equate it to 0. I'm not going to do that math part. I'm just going to concentrate on the result. What will be the result that I get? I will get the relation between small r and capital R, and that is what you have to remember. And the result is small r has to be equal to capital R. In that case, we get the maximum power dissipated to the load, and this is known as the maximum power transfer theorem. The first point of maximum power transfer theorem is if you want maximum power to be delivered to the load, if you want maximum power to be delivered to the load, if you want maximum power to be delivered to the load, the internal resistance, no, the external resistance R should be equal to the internal resistance of the battery. Do we understand this, or this has gone above our head saying bye bye? That is the first point. I don't see raise hands. Are we there, everyone? Ah, alive and kicking, same dimension. Please don't disappear in the other dimension. And if you are disappearing, please let me know. So I will, I will also try to catch up with you in the next dimensions. D is what is the value of that maximum power. So what you got to do is just put capital R in place of capital R, put small r, and you will get your maximum power. I am going to do it for you. You have to remember this. Maximum power becomes E square divided by 4 times small r. That is your maximum power which is dissipated in this particular circuit. And you cannot forget this because there could be a question lined up in your JEE based on this, because this question has not come in the whatever paper I remember. It has not come. If it has come very recently, I don't know, because recent papers I have not seen. I saw last year JEE advanced paper, JEE main paper I don't see. So there is no use of seeing them. So according to JEE advanced, it has not come in a while. So do we understand this? Yes or no? No or yes? Huh? Have you noted this down, everyone? Yes or no? Yes, sir. Then we move ahead, sir. The next thing is this graph, and remember this graph. This is how the graph looks like. Shall I move ahead? Huh? Huh? No one is saying anything. Have you noted this down, bacha? Pakka na, sir?
Yes, sir.
Pakka is dangerous. This is how the graph looks like. Power is maximum at this junction, and here the value of small r is equal to capital R. Draw this graph. Now, for any given power, that is the next thing that you have to see. For any given power, you will have two values of R where you can have that power. Do you see this? These are small thing, better. I'm giving you everything that is possible that can come. Now, I don't have enough time to prove everything, make big quadratic equation, solve the quadratic equation, give you the roots, and then show it to you that this is going to come as this. I'm giving you them as points. And that is what I did with the previous question, that truncated cone. I gave you the resistance before, because there's no point for me to actually solve it and get your answer and stay happy. Okay, I could solve this question. There's no point of doing that. The point here is that if this question comes, you have to just take it and go. Now, for any given power, you will have two values of R, capital R, for which that power is possible. Do we understand this? And it can be proved by simple maths, which I don't have the time to do, that this two resistance R1 and R2 will be equal to R square. Keep this thing in your mind, because if it comes in JEE, you will not have time to solve it. For any given power, And that is why I have shown you this graph. For any given power, there are two values of resistance with that power is possible, and R1 into R2 will be equal to R square. Okay, do we get this? Yes or no?
Yes, sir.
Okay, here last point, which I don't think can ever come, but still, since this is the point number F, what is the efficient? Oh, what is the efficiency of the battery in this case for maximum power transfer? No one is going to ask you this, but the efficiency of the battery is 50% in this case. This is all about maximum power transfer theorem that you should know. Okay, I'll give you 2 minutes to note it down. These type of questions are going to come very soon in magnetic field. So let's get ready with these type of questions. A wire of resistance R is bent into a circular ring of radius R. Equivalent resistance between point X and Y on the circumference. This is a wire. The radius is given as R. A wire of resistor R, the resistance is capital R, is bent in the form of a circle of radius R. Between any 2 points, the angle is alpha. You have to find the equivalent resistance between these 2 points. This is for the next chapter, which is magnetic field, that we have to understand how it happens. Okay, I'll give you 2 minutes to do this. Okay, so how are we supposed to solve this? Any idea, anyone? I have to find the resistance between these 2 points, X and Y. How are you going to find out the resistance between X and Y? Yes, please give me some ideas. No one has any idea? It's a simple series parallel combination. I have to find the equivalent resistance between X and Y. How will I find it? How many resistance you see between X and Y? Do you see any resistance between X and Y? Yes or no? Do we see any resistance between X and Y? Yes or no? Yes or no? What are the resistors that you see? How many resistors you see? 1, 2, 3, 4, infinite. How many? How many? How many?
Two, sir.
2. Can you tell me which are the 2?
Blue and Z.
Yes. What are the 2?
W and Z.
W and Z. Okay. So if I call this as the green one, and I will call other the blue one, the green and the blue registers are there. Yes or no? Let me call this register as R1, and let me call this register as R2. Can anyone tell me what is the value of R1 and R2? If I call the green one as R1, if I call the green one as R1, and if I call the blue one as R2, what is the value of R1 and R2? How will I find it? This complete circle, what is the resistance of this complete circle? What is the resistance of this complete circle? How much? R. Resistance of a wire is equal to rho L by A. The wire is same. Rho is same. The area is same. So what we can understand here is resistance will be what? Resistance will be what? Same wire. Proportional to length, sir. Well done, sir. Now resistance is proportional to length. Can you tell me what will be the value of R1? What is the length of this segment? The segment W. What is the length of this segment?
2 alpha.
So the length of this segment is alpha into R. Alpha into R is the length of this segment. And capital R is proportional to the total length, which is 2 pi R. So can you now tell me what is the value of R1 equal to? It will be equal to this multiplied by R divided by 2 pi R. Yes or no?
Okay.
Pakka? Pakka?
Yes, sir.
So this is R into alpha by 2 pi. That is the value of R1. You can say that this R1 is directly proportional to alpha because 2 pi is again full angle, full circle. Okay, on similar lines, can you tell me what is the value of R2? R1 is equal to alpha upon 2 pi.
Minus alpha into R.
So R2 will be R into 2 pi minus alpha divided by what? Divided by what? 2 pi. How are this R1 and R2 connected?
Parallel.
Now can you tell me the result? What will be the effective resistance between X and Y? Equivalent resistance between X and Y. R1 is connected in parallel with R2. So the answer will be R1 R2 upon R1 plus R2. Can you now tell me the result and tell me which option is matching? Which option is matching? Which option is matching, beta? Anyways, once you get this option, yes,
Option A.
option A is the correct answer. Was it so difficult that you could not do it on your own? Option A. Option A is the correct answer. Do we understand this? Option A is the correct answer. Everyone understands this, boys and girls? Girls have disappeared.
Understood, sir.
Why? Was it so difficult to get this? Was it so difficult? There were just two resistors, they were in parallel, you just had to find out their resistance. Anyways, anyone understood this? Can you move ahead to the next question? Pakka?
Yes, sir.
Okay. Now again, remember this question probably may not come in current electricity. Same question might come in the next chapter. No, they will not ask you the resistance in that chapter. What they will ask you is, there is a current which is flowing in this wire. Let me call that current as I. Now at this point, what happens? This current will get bifurcated because there are two resistors. Yes or no?
Yes, sir.
Ah, there is a current. Let me call it a blue current. This blue current goes in this branch I1, and then this green current comes in this branch. I hope you are able to understand. Same thing, na? This green current comes in this branch. Let me call this as I2. So again, I1 and I2 will match, and you will have the current I going back. Yes or no?
Sir.
You have to find out the value of I1 and I2. What will be the value of I1 and I2? Do we get the question? The resistance of the total wire is R and the angle is alpha. Everyone understands this? Boys and girls? Are we there in the class?
Yes, sir.
Boys are there, girls? Disappeared? Another dimension somewhere? Another universe? Looks like. Are we there? Lost in dimensions. Lost in space. Anyways, I hope the rest of you are there. And we will
Sir.
be. Yes? Everyone is there?
Yes, sir.
Oh, thank God. I thought I've lost you. Okay. We have to find out the value of I1 and I2. I1 is the current in the blue branch and I2 is the current in the green branch. You have 2 minutes to do this. So how I'm supposed to do this? Remember, in parallel branches, current is distributed in inverse ratio of resistance. So how much will be I1? I1 will be equal to I into the resistance of the second wire. What is the resistance of the second wire?
R alpha by 2 pi.
Oh, sorry, I'm writing R2. R
Alpha by 2 pi.
by 2 pi divided by the total resistance, and total resistance you know is R. Yes or no?
Sir.
It becomes I into alpha by 2 pi. It is a larger section, but it has smaller current. Do we understand this? Why it is smaller? Because current divides in inverse ratio of resistance. Do we understand this, everyone?
Sir.
Boys and girls, I'm not getting any girls' voice. We there? Or lost in space?
Yes.
Pakka na? There na? Okay. Similarly, I2 will be equal to I into R into 2 pi minus alpha divided by 2 pi divided by the total resistance. Total resistance is going to get cancelled, and that will be the answer for I2. I2, the branch is smaller, but the current is higher. That is the point that I wanted to let you know. I hope I made my point absolutely clear to everyone. Yes or no?
Sir. Sir.
Tayo. Everyone has noted this down?
Noted, sir.
Okay. Now we will just go quickly into this part because might be required. Shall we move ahead?
Yes, sir.
Okay. EMF of a battery or a cell, we have already seen this. I will go through it very quickly. If you want to note it down again, you can note down the things that we have done. If you don't want, we'll just quickly go through this. EMF of a battery or a cell. So we know that electromotive force is the work, EMF of a battery or a cell is the work done per unit charge in moving a positive positive charge from the positive terminal towards the negative terminal inside the battery. Do we understand this? Everyone remembers it?
Yes, sir.
You can also write EMF as the potential difference across the terminals of the battery when it is not giving, when the battery is in open circuit. Yes or no? Do we remember it? Okay, I'm just giving you a glimpse of it. If you haven't remembered it, because I will be needing this for one of the topics that we are going to do. So that is why I have to go through it once again. On what all factor does EMF depend on? This point probably we did not discuss. On what factors EMF depends on? Nature of the electrolyte and the metal of the electrolyte. On what factors EMF does not depend on? Area of the plates, distance between the plates, and quantity of electrolyte and the size of the cell. EMF of the battery does not depend on this. Do we understand this? Yes or no?
Yes, sir.
Huh?
Yes, sir.
पक्का ना सर?
Yes, sir.
Everyone has noted this down, or are you noting it down? So I'll give you time, else I will move ahead. Are you noting it down?
Read down, sir.
Okay, I'll give you time. Note it down. Then we had also seen bacha two types of battery or two types of cell. One was an ideal battery or an ideal cell. It did not have any internal resistance and no energy is lost. Do we remember this? Ideal battery, and this is how you represent an ideal battery. In some cases, you will find circuit with an ideal battery. In some cases, you might find a small resistance put with the battery or the cell that is known as a real cell or a non-ideal cell. And the difference between real cell and non-ideal cell is very simple, that a non-ideal cell has a resistance and therefore some energy is lost in the form of heat. Do we understand this? Yes or no? No or yes? Do we understand this, bacha? Non-ideal and real. Have you noted it down, bacha?
Yes, sir.
Okay. What is the internal resistance of a battery or a cell? Internal resistance of a battery or the cell is the resistance offered by the electrolyte of the cell. It is the resistance offered by the electrolyte of the cell when current flows through this. And this is how you represent a battery with a resistance, internal resistance. On what all factors the internal resistance depends on? The first factor, if the distance between the two electrodes increases, internal resistance increases. Do we understand this? It depends. Internal resistance of the cell depends on these. EMF does not depend on these factors, but the internal resistance of the battery depends on these factors. I hope you are able to understand this. If area of the electrolyte, now these questions can come as separate questions in your exam. If the area of the electrolyte increases, R decreases obviously. If the concentration of the electrolyte increases, R increases, because this comes because of the electrolyte only. If the temperature increases, resistance, internal resistance decreases. These are all These are all information-based questions which you will have to remember. I'll give you 2 minutes to note them down. Once you are done, please let me know. Then the next thing that is asked many a times in the examination is the potential difference across the cell or the battery. In most of the cases, the cell or the battery will be non-ideal because it will be having some internal resistance. So whenever someone is asking you the terminal voltage, he is asking you the terminal voltage. That means he is asking you the potential difference between the points A and B, which are the ends of the cell. He is asking you the potential difference across the cell. So terminal voltage or terminal potential difference is nothing but the potential difference across the two terminals of the cell when the battery is connected. Now remember, for ideal batteries, for ideal batteries, for ideal cell, this terminal voltage V is always equal to the EMF E, whether the cell is connected or whether the cell is disconnected. Do we remember this? I'd already told you. For non-ideal cells,
Not equal to EMF.
for non-ideal cells, for non-ideal cell, V will be equal to E. When will V be equal to E?
Circuit, sir.
Yes, when the circuit is open. When the circuit is open, not connected, or the circuit is open, then my V will be equal to E. Remember all these small points. V will not be equal to E when
Circuit is closed.
circuit is closed. Well done. When the circuit is closed, it will not be equal to E. It can be more than E, it can be less than E. And we will see both of the cases now. We will see both of the cases now. Have you noted this down?
Minute, sir.
Let me know once you are done. So the first case is when the battery is getting discharged. When the battery is getting discharged, current flows outside the battery. I'm talking from the positive terminal to the negative terminal. Do you see this current flowing like this from the positive to the negative terminal? Yes or no?
Yes, sir.
So this is the case where battery is giving current or the battery is discharging. In this case, my dear friends, this potential drop or terminal voltage is less than your EMF and it is equal to E minus IR. Do we see this? Yes or no? No or yes? Huh?
Yes, sir.
Do we see this?
Sir.
Okay. Now we have done this case in maximum power transfer theorem, but again I will repeat so that this thing gets into our head and we are confident. In this case, the current given by the cell will be equal to E upon R plus R. Yes or no? Do we understand this? Are we able to understand these points? Yes or no?
Noted, sir.
Okay. Now I can put the value of I from this equation into the pink equation, and from there I will get a very important result, and that important result is I can find out the internal resistance of the battery by this formula. It's a very important formula that I am showing you. The internal resistance of the battery or the cell can be given by this revolutionary formula, E by V minus 1 into R. This is what we have done this entire exercise. Are we able to understand and correlate? Yes or no? Then there comes this one, your maximum power transfer theorem. You can again write it here. The power dissipated to the load will be this much, and this power will be maximum if R is equal to capital R, and this maximum power will be equal to E square by 4R. Are we able to relate everything together? Yes or no?
Sir.
No. Yes.
Yes, sir.
Pakka na, sir? And you
Yes,
can
sir.
remember that graph of maximum power transfer theorem, a very important case that you must understand here, because I will be using this formula very soon, maybe in the next class. Then please remember that we got it in this way. If you don't remember it, what else? Nothing. I'll just show you. I'll just show it to you. What else will I do? Everyone understands this? Yes or no? Pakka na, sir, or it has gone above our head saying bye bye, sir. Bye bye, sir. बहुत हो गया, sir. छोड़ दो, sir.
Sure, sir.
Have you noted this down?
Sir, for maximum it is E square by 4R square, sir.
Huh? Maximum power is?
Square by 4R square, sir.
Take a deep breath. Deep breath, and then give me the answer. E square by 4R square. Did I write that? Did I write that? 4R square. Did I ever write it? It is dimensionally wrong. It cannot be correct. So if you have ever written it anywhere, you must correct it. If you have written it anywhere, did I write it anywhere? Did I write it anywhere? I never wrote it anywhere. I think so. Please correct it. And stay in this universe, yeah. This is a good universe to live. Okay, here comes the next question. The next case where what? where your cell is getting charged, and the cell is getting charged by an external source. The cell is getting charged by an external source. Have you noted this down previously? Anyone noted it? Then comes the case where we are charging it. So this is an external battery E1, and you can see now that the current is flowing in the reverse direction in this battery, and therefore this battery is getting charged. Do we see this? And in this case, what you can see, my dear friends, is your V, the potential difference across the terminals, is more than the EMF because it is getting charged. Anyone understands this? This battery that I've applied, that I've put here, is more than the other battery, and therefore you have more. And therefore you have more potential drop. Terminal voltage is more. We understand this? Yes or no? No or yes? Have you noted this down? Or should I give you time? One time? Okay. Let me know once you are done. Okay, let's move ahead with the third case. And the third case is a very simple case. It's an open circuit. Open circuit means the outside resistance is infinite. There cannot be any current. If there is no current, the battery voltage, terminal voltage and EMF would be same. I have already given it to you. Yes or no? Yes or no?
Sir.
One more thing. The opposite of open circuit is known as short circuit. You understand the meaning of short circuit and open circuit?
Sir.
Short circuit means we have connected the two terminals of the battery by a wire with zero resistance. Yes or no?
Yes, sir.
That is known as a short circuit. So if it is a short circuit, the potential difference across the two terminals will definitely become zero. I hope you understand this. Yes or no? No, yes.
Yes, sir.
Pakka no, sir. I hope my
Okay, sir.
mehnat is not going down the drain. I hate drains. It's not going down the drain, no? Huh? Or am I contributing towards the drain of Hyderabad? I hope not. This is open circuit and this is short circuit. I hope you understand open and short circuit. I'll give you 2 minutes to note it down. And then we'll move on to some Q's and A's. And summarize some points. One point. Remember, this confuses a lot of students, so it is necessary that I clear this. Sometimes we have this common misconception, and I've seen a question on this, that current in the circuit will be maximum when the power consumed by the load is maximum. Remember, it is not correct. Current is maximum when R is minimum or zero. And then the power through the load, since there is no resistance, the power through the load is zero. But power is maximum, which is E square by 4R, when the value of external resistance is R. Do we understand what I'm saying this? Just trying to sum up everything. And the value of current is E by 2R in that case. So remember this. Don't forget this. Don't confuse the two things. Current maximum and power maximum, they are different phenomena altogether. I hope we have understood this. Yes or no? No or yes?
Yes, sir.
Have you noted it down?
think so.
Let me know once you are done so I can move on to some Q's and A's quickly. Well, then here comes the first question. These are the type of questions you will find in your examination hall. A new flashlight. Why it is written new? So that the EMF remains same. A new flashlight, you must understand that once a battery is used, with time its EMF decreases. A new flashlight of EMF 1.5 volt gives a current of 15 amperes. When connected directly to an ammeter, voltmeter, next class. When connected directly to an emitter of resistance 0.04 ohms, what is the internal resistance of that battery? Now we are dealing with internal resistance of battery. Battery is also an electrical device. It gives you potential difference which allows the current to flow. Current can only flow because of potential difference. Yes. What is the answer for this one, my dear friends?
0.06.
0.06, and that is correct. You just have to find out current is equal to E upon capital R plus small r, and capital R I is given 15 amperes. This is given as 1.5, external resistance is 0.04 plus small r. From here, you should be able to get the value of small r, and I think it is going to come as 0.06. Do we understand this, everyone? Well done. Now comes this question for which I was preparing everything. This question confuses a lot of students, and I hope you can give the answer by what we have already done. For a cell, the terminal potential difference is 2.2 volt when the circuit is open and reduces to 1.8 volt when the circuit is connected across a external resistance of 5 ohms. What is the internal resistance of that battery or the cell? Question number 2 coming up for you. When the circuit is open, it is 2 volt, 2.2 volt. When the circuit is closed with a resistor of 5 ohms, it becomes 1.8 volt. You have to find out the internal resistance of the cell. I'll give you 2 minutes to give me the answer. Well, 10 by 9 is the correct answer. Remember, when the circuit is open, 2.2 volt. When the circuit is open, 2.2 volt is the EMF of the battery. Yes or no?
Yes, sir.
When the circuit is closed, the voltage becomes 1.8 volt. This is the potential difference across the battery when the battery is connected. And we have seen a very good result. Which has E, V, and R. Remember the result. R, internal resistance of the battery, is E by V minus 1 times capital R. Do we remember this result? This is the result that we can use here. So internal resistance will be equal to 2.2 divided by 1.8 minus 1 multiplied by 5. This is the answer that we are looking at. And I think the option you will get is 20 by 18, or the internal resistance R will be 10 by 9 ohms. Everyone got this answer?
Sir.
Well done. Girls, are we getting these answers? Good. Well done. One more. Do it fast. I'm expecting question on this nature because it is not only used here, but it is also used in one of the most difficult thing that no one understands, potentiometer. We'll be doing the same thing in a potentiometer. This one comes, the next one. Question number 3. Solve it fast. The internal resistance of a cell of EMF 2 volt is 0.1 ohms. It is connected to a resistance of 3.9 ohms. What is the voltage across the cell? I'll give you 1 minute to give me the answer. Well, yes, C is the correct answer. How can you do this? You can just use the same formula. Voltage across the cell, they want to know. Voltage across the cell. So you can use this formula. Remember, R is equal to E by V minus 1 times capital R. Everything here is known. Internal resistance R is 0.1 is equal to EMF is 2 by V minus 1 multiplied by the external resistance is 3.9. Just you solve for V and you will get the value of V. I guess the value of V is 1.95 that is coming from here. You can get it this way, or if you don't want to do it this way, you can first find out the current. Current is E upon R plus R. Do we understand this? Everything is given here. You can find out the current. Once you get the value of current, the potential difference will be E minus IR. This way also you can get the potential difference. Doesn't matter how you do it as long as you do it correctly. We understand this? Yes or no? No, yes.
Sir.
Everyone got this? Any of
Sir.
the method is good. You can use any method which gives you confidence. And here comes the question from JEE. This is the question from JEE, IIT-JEE of my times. A battery of internal resistance. Question number 5. A battery of internal resistance 4 ohm is connected to a network of resistance as shown. In order to give the maximum power to the network, the entire network we have to give maximum power. What should be the value of R? I will give you 2 minutes to give me the answer. Okay, then I'll do it. This battery has an internal resistance. I just have to find out how much is the external resistance. This is R. This R and R are in series. It becomes 2R. This 2R and 2R are in series. This R and R are in series. It becomes
Option C, sir.
now R, 2R, R, 4R. We balance V-stone bridge. So this बीच वाला resistor goes to भगवान के पास. Then the ऊपर वाला 2 are in series. R plus 2R, 3R. The नीचे वाला 2 are in series. 3R. And नीचे वाला is 6R. This 3R and 6R are in parallel. Total resistance of this entire circuit becomes 2 times of R. Do we understand this?
Sir.
And this 2 times of R has to be the internal resistance of the battery. Internal resistance of the battery is 4. So the value of R is 2. Was it so difficult? Was it so difficult? Do we understand this, or this has gone above our head saying bye bye?
Yes, sir.
How many of you got it on your own? 1, 2, 3. Good one. Chalo. Maximum power transfer theorem came in 1995. Let's come once or twice after that as well. Anyways, comes this one, and I'm expecting, remember, these are the types of questions. In the next class, I'll show you the questions that are coming in JEE these days. That is why I'm insisting so much on doing all these questions. So that when the question comes in the JEE, you will feel, "Arey, ye to kiya hua hai. We have done this." A torch bulb rated as 4.5 watt and volt Whenever bulb comes, watt and volt will come. Watt and volt, my dear friends. Watt and volt is connected as shown in the figure. What is the EMF of the cell needed to make the bulb glow at full intensity? Full intensity, the bulb should glow. Please solve this question. These are the questions that are going to come in the exam, my dear friends. Please do it. Everyone is understanding what we are doing? Anyone has any doubts? Please raise your hands. See, the questions are pretty simple. The only thing you have to work on is to get them correctly. And remember, your first target is to do 15 questions. 15 questions in physics, 15 questions in chemistry, 15 questions in maths, and you get to 120 marks. And 120 is a good enough mark to get to any NIT. 15 questions is your target. 15 questions in 1 hour. 1 question in 4 minutes. I'll give you 2 minutes for this one though. Okay, then what I'll do is I'll give you this question as a homework that you have to try. Now, I'm going to give you as homework. I'll give you a hint. It's a very simple question. Basically, you have to find out the value of this EMF. And how do you find out the value of this EMF? This EMF is equal to, if you can, find out the current in the circuit and find out the potential difference between these 2 points, which is V. And you already know how much is V. You can write it as V plus I into R. So only 2 things you have to calculate here. One is the value of V, which is given to you. You just have to open your eyes and see. And you have to the value of current in this branch. If you can these 2 things, you will get the answer, and the answer is option D, 13.5 volts. That is correct. Still, I will give you time. I will discuss this question in the next class. I've done so many questions because I think, I feel, I know that these type of questions are going to come, and that is why I'm insisting so much on circuits questions like this. I will see you in the next class. And next class, I will show you what type of questions are coming in the past 2-3 years, and you will see how easy those questions are. And that is why it is easy to score a score 120, 140, 150 is very easy to score in a JEE. So we'll continue our effort in the next class. I hope everyone enjoyed today's class. Everyone understood what we have done in today's class? Yes or no?
Yes, sir.
We'll meet again in the next class. Remember, the next class, that is tomorrow, is at 1:30. If it is remember that time, and do not mess up with the time. Take care. God bless all of you. Bye bye.
Thank you, sir.
Bye beta.
Bye, sir. Bye, sir.
Bye.